40% of all of the marks in your GCSE Science are for pure factual recall, so I've written a set of questions to test whether you know the key facts that are listed in the specification. You'll find the link to the questions in the description below. The standard international units for energy are joules. Watch out for that capital J, it's really important. There are 8 different energy stores: a magnetic store, a kinetic store, a thermal store, a gravitational potential store, a chemical store, an elastic potential store, an electrostatic store, and a nuclear store. Hot objects are thermal stores of energy. Moving objects are stores of kinetic energy. Objects that have been raised in a gravitational field are a store of gravitational potential energy. A stretched spring or elastic object will be a store of elastic potential energy. The 4 ways that energy can be transferred are mechanically, electrically, by heating, or by radiation. This means light or sound. To calculate kinetic energy, you need the equation half mv squared. The standard international units for mass are kilograms, and the units for velocity are meters per second. The equation for elastic potential energy is half multiplied by the spring constant multiplied by the extension squared. Extension means how much longer has an object got, so you calculate it by taking the final length and subtracting the starting length. The units for extension are meters. A spring has reached its limit of proportionality when it's stretched to the point where, when you remove the load, it no longer goes back to its original shape. The equation for gravitational potential energy is energy is mass multiplied by gravitational field strength multiplied by height. The SI units for height are meters. Gravitational field strength means how strong is the gravity you're feeling per kilogram of mass. On Earth, G has a value of 9.8 newtons per kilogram. To calculate the change in thermal energy, you take the mass of whatever is changing in temperature, multiply it by the specific heat capacity, and then multiply that by the change in temperature. The SI units for specific heat capacity are joules per kilogram degrees C. Specific heat capacity is the amount of energy that it takes to raise the temperature of 1 kilogram of a substance by 1 degree C. The delta sign, or the funny triangle, in front of the E and in front of the T both stand for change. It's the change in energy and the change in temperature. Power is the rate at which energy is transferred or work is done. In other words, the higher the power of an appliance, the faster it's able to transfer energy. The 2 equations to calculate power are energy divided by time and work divided by time. But remember, both energy and work are measured in joules, so it's essentially the same calculation. The SI units for power are watts. A watt is the same thing as a joule per second. In a closed system, energy can be transferred usefully, it can be stored, or it can be dissipated to the surroundings, but it can't ever be created or destroyed. A system is just an object or a group of objects. And when we talk about a system being closed, that means that no matter and no energy can get in or out. When energy dissipates, it spreads out so much that it's no longer available for useful work. Waste energy can be reduced either by reducing heat loss by insulating an item, or by reducing friction, air resistance and other drag forces by lubricating it. This next question seems a little bit silly, but it is specifically mentioned in the specification. So in case you weren't sure, if a building has thinner walls or higher thermal conductivity, then it will cool down faster. The 2 equations to calculate efficiency are useful output energy transfer divided by total input energy transfer, or we can just cross out energy and substitute in power. Basically what we're interested in is the useful output as a fraction where the denominator is the total input. We can also multiply either one of these equations by 100 to turn it into a percentage. The 3 fossil fuels are coal, oil and gas. An advantage of using fossil fuel power stations is that they're very energy dense, and also they're very reliable. However, They run on fossil fuels, which are not renewable, and also burning fossil fuels releases carbon dioxide, which is a greenhouse gas. Nuclear power stations tend to run on uranium or plutonium. Again, these are very energy-dense fuels, much more so than fossil fuels. However, even under normal operation, you have to get rid of the nuclear waste somehow, and there's also the risk of a nuclear accident. A renewable energy resource isn't infinite, but it can be replaced as fast as we're currently using it. The 7 examples of renewable power that you're supposed to know about are biofuels. In other words, you ferment sugar or corn in order to make bioethanol, which can then be burned in the same way that you would in a combustion engine with fossil fuels. Wind power, where you use wind turbines. Hydroelectricity, where you have a reservoir and the water is let out of the reservoir and is used to turn a turbine. Geothermal power, which uses the heat of the earth. Tidal power, solar power, and wave power. The biggest advantage of wind turbines is that they're a source of renewable power, so they're not going to run out. Also, they don't release any carbon dioxide. And that's important because carbon dioxide is a greenhouse gas and is contributing to climate change. On the other hand, they're not super reliable. A wind turbine will only generate electricity when it's windy, which it isn't all the time. Also, they're unsightly, and so not everybody wants them built near their homes. Thank you very much for watching, and I hope you're now feeling well on your way to revision for Physics Unit 1. If you found this video useful, then don't forget to like and subscribe for more GCSE Physics resources coming soon.